So we've decided that we need to make an estimate, and we understand the class of estimate that we're trying to prepare. We have completed an appropriate level of engineering to define the project. Now, how do we go about actually preparing the estimate? In this lesson, we'll discuss different estimating techniques and the class of estimate that they support. This chart lists the most common types of estimate used for projects. In general, the top two estimate types on the list can be considered top-down estimates. They're used for Class 5 and Class 4 types of estimates. The bottom of the list can achieve more accuracy. Both the semi-detailed estimate and the detailed estimate can be considered bottoms-up estimates. In this lesson, we'll discuss each estimate type, when it might be used, and how to prepare it. The first estimate is an analogous estimate. In this approach, we use our experience and the organization's experience to prepare an estimate based on previous projects. First, we select a similar project or projects, review the history of what it cost, and then use these values to estimate the cost of our project. We may make some adjustments to make it better reflect our project. For instance, we may adjust the estimate to reflect the changes in pricing for today's rates versus when it was completed. We may factor the cost to account for slight changes in scope or size. At the end of the day, the estimate is based on experience. In the simplest case, it might be, last time I did this, it cost X dollars. This time I think I can do it for Y. Analogous estimates are almost always considered Class 5. Unless the organization has done the project many times and the scope is always the same, Class 5 is the most we can achieve. Next, we want to look at parametric estimates. We will discuss two types of estimates: capacity factored estimates and equipment-based estimates. In a capacity factored estimate, we curve fit costs from similar projects based on the capacity or the size of the project. The capacity might be based on units of throughput, on square foot of usable space, or it might be based on volume. Each project type and each industry will have its own definition of capacity. The key to this type of estimate is good historic data. The formula you see here fits most types of projects. To use the formula, you curve fit historical data using regression analysis to determine the exponent E. This will give you the formula for your situation. In many industries, estimators have already done the analysis, and the typical exponent for your type of project is available from the literature. For instance, for process plants, we typically see an exponent of 0.7. For building, it's typically close to 1.0. In our text project management toolbox, they report the exponent for software estimating is 1.4 based on lines of code. To use the formula, simply divide the capacity of your project by the capacity of the reference project and raise the result to the exponent E. We multiply this result times the cost of the reference project to give the estimated cost of the new project. This is a fairly simple approach, can be used for both Class 5 and Class 4 estimates as a rule. In many cases, we adjust the final answer for changes in pricing information between the time the reference project was completed and the time when our project will be complete. In this case, the adjustment is made by increasing the final price by the percent increase in the base material and labor costs we expect. In equipment-based estimates, we can use either historical factors or proprietary software to develop the estimate. In both cases, we should develop the equipment or major component descriptions and sizes to describe the project. In the case of a factored estimate, we price each component and then multiply it by a historic factor to incorporate the minor items, the cost of engineering and the cost of construction. For instance, in a process plant, we might want to estimate the cost of a pump, then multiply it times a factor to include the cost of concrete, wire, steel, pipe, valves, installation, labor, etc., to fully install the pump. In the case of using proprietary software, it is a very similar approach, except the software program takes the descriptions and based on the model it uses, it'll develop the cost basis for the project. These techniques can be used in both Class 4 and Class 3 estimates, depending on the accuracy of the underlying factors and programs. Next, look at semi-detailed estimates. A semi-detailed estimate, as its name implied, is a hybrid approach. It is often used in Class 4 and Class 3 estimates, where the level of engineering is progressing, but not quite far enough along to fully define the project. In this case, we use detailed estimating or bottoms-up techniques on those sections of the project that have been well defined, and we use factoring and equipment modeling on those sections of the project that are not well defined. This approach is also used in cases where there's not sufficient historical data to use other estimating techniques. For instance, suppose you have a unique section of a project that is different every time you do a project. It might be landscaping, or it might be a storage facility, or it might be security. Whatever it is not a good candidate for factoring. In this case, you'll be forced to make some assumptions and develop your own list of materials and make your own estimate of the number of hours to complete the task. This will be a forced detail, and you can combine it with the more standard sections which are estimated using factors to get a semi-detailed estimate. The final estimate type we will discuss is the detailed estimate. A detailed estimate or bottoms-up estimate is based on counting the quantity of each element of the project and then multiplying it times its cost to develop the estimate. Typically, Class 1 and Class 2 estimates are developed in this manner. Engineering must be sufficiently complete that you can develop the plans and sketches of the final product. In each case, we can quantify the number of each component in the project, including the material types and quantities, and also the number of hours it will take to complete each task. Each item is priced based on our estimating plan approach, and a complete cost of the facility is built up component by component. The last activity in preparing your estimate is the estimate review. Estimate reviews are a real key to producing high-quality estimates. Getting input from others will significantly improve the accuracy and repeatability of your estimate. I typically recommend the following 5 levels of review. First, a functional review. This review by a peer group looks for inconsistencies in methodology and approach. Are we following the right process? A discipline review. Review by each of the disciplines contributing to the scope and pricing of the estimate to ensure its understanding. Discipline review also confirms whether you're meeting the requirements of the project. Third, a project review. Review the project with the leadership of the project to ensure that the project execution is correctly reflected. It also looks at the impact from outside forces. We need a project sponsor review. This is a review with the project sponsors to obtain their endorsement and confirm consistent with the project charter and the organizational strategy for estimates. The project sponsor review also brings the resources of the organization to bear. Is there a better way to do this? Are there changes in the market that may impact the project? Can we get the resources we need to complete the project? And finally, we need a customer review. A review by the ultimate customer is important to confirm and validate the results and to confirm it also meets their expectations. In my experience, the value of this multi-layer review is the diversity of the process. Good reviews will spend the bulk of the time reviewing the basis of estimate. Estimate reviews should focus on the techniques used to develop the estimate and whether they are appropriate for the goal you're trying to reach. Are they consistent with the organization's standards? They should focus on how you develop individual components of the estimate. Are they repeatable? Did you use good methods to quantify the estimate? Is the pricing appropriate? Did you consider the right factors in the estimate? The estimate review should also look at the project plan. Did you accurately reflect the scope, schedule, and budget in the estimate? Have we accounted for all the project risk? And does the estimate reflect the proposed execution approach in the legal environment? Lastly, the estimate review looks at the numbers. If the first part of the review is done correctly, the final part is a math exercise to see if it's all been put together properly. So we looked at the different estimating techniques to use for the estimate. Which techniques will we use will be based on the amount of information we have at hand and the amount of engineering which is complete. The more information, the more detailed the estimating approach should be. As you may be guessing, estimating contains a lot of art. There is never one single approach or technique that applies in all situations. The key is to prepare a good estimate basis and use the estimating review process to validate your approach. The bottom line is, project management is a team sport. Use the resources in your organization to help you. In the next lesson, we'll look at converting the cost estimate into a cost baseline.